Ever wondered how something as intangible as wind can power entire cities? Get ready to uncover the genius behind it. Today, we're unlocking the secrets of wind turbine blades, the massive, elegant structures that turn invisible air currents into real, usable electricity. From their aerodynamic shape to their cutting-edge materials, we'll reveal how these marvels of engineering transform gentle breezes into gigawatts of clean energy. Every time you see those colossal turbines turning slowly against the sky, remember they're doing something extraordinary, extracting energy from thin air. But here's the challenge. Air is unpredictable. It shifts, slows, and surges without warning. So how do you design a blade that can capture that ever-changing flow efficiently? The answer isn't just in size, it's in subtlety. Each curve, angle, and twist on a turbine blade hides a century's worth of aerodynamic insight. What looks like a simple propeller is in reality an incredibly sophisticated energy machine. It's not brute force that makes it work. It's elegance, precision, and a deep understanding of fluid dynamics. At the heart of it all lies the same principle that keeps airplanes flying: lift. But while airplane wings lift planes upward, wind turbine blades generate lift sideways, making them spin. When wind passes over a blade's curved surface, it creates a pressure difference. Higher pressure on one side, lower on the other. That imbalance produces a force, lift, that drives the rotation. But it's a delicate dance between lift and drag. Too much lift, and the blade stalls. Too much drag, and efficiency plummets. Engineers have spent decades refining airfoil shapes, slender at the tips, thicker near the base, to maintain perfect balance even as wind speeds fluctuate. Some designs even mimic nature. The humpback whale's flippers inspired blade edges with tiny bumps called tubercles, which help maintain smooth airflow and prevent stalling. The result? More power, less turbulence, and quieter operation. Of course, perfect aerodynamics mean nothing without the right materials. Wind turbine blades stretch up to 120 meters long. That's taller than the Statue of Liberty. To handle that scale without snapping, they need to be both incredibly strong and surprisingly light. That's where advanced composite materials come in. Layers of fiberglass and carbon fiber bonded with epoxy resins. These materials provide the ideal strength-to-weight ratio, allowing blades to flex slightly under stress without breaking. Manufacturing them is an art form in itself. Each blade is built in massive molds, often in one seamless piece to avoid weak joints. Precision is everything. A single air bubble in the resin could weaken the structure. And then there's durability. These blades must survive decades of battering from rain, hail, and even lightning. Some are coated with nanomaterial-based finishes that resist erosion, while others have embedded sensors that detect stress and fatigue before failure occurs. Today's turbines are getting smarter. Many feature active pitch control, a system that adjusts the blade's angle in real time, optimizing its performance for changing wind speeds and protecting it during storms. Cutting-edge innovations include vortex generators, tiny fins that improve airflow, and de-icing systems for cold climates. Engineers are even experimenting with segmented blades that can fold or flex, making transportation easier and performance more adaptable. Looking ahead, researchers are exploring self-healing materials and bio-inspired coatings that could make turbines last twice as long while capturing even more energy. Offshore wind farms, where winds are stronger and steadier, are the new frontier, pushing the limits of size, strength, and design like never before. When you step back and look at a wind farm, what you're really seeing is a symphony of engineering and nature in perfect harmony. Each blade turning silently against the sky represents years of innovation, collaboration, and imagination. These turbines have turned wind, once seen as unpredictable and uncontrollable, into one of humanity's most reliable sources of clean energy. And the evolution continues. With every new material, shape, and algorithm, we move closer to a world where renewable power isn't the alternative. It's the standard. So next time you see a wind turbine on the horizon, take a moment to appreciate the genius hidden in every curve and motion. Because in the end, these blades don't just capture wind, they capture human ingenuity itself.